first known interstellar object, Oumuamua.
Story of tonight's lecture, small object Oumuamua.
A mysterious comet landed on our solar system and has caused daunting problems. It has led to several experiments and speculations by scientists with no actual conclusions. Luckily, the James Webb Telescope released the first picture of this intruder named Oumuamua. But what's going on with the flight behavior of this space visitor? Will this strange interstellar object pose a threat to Earth? Join us as we talk about the real image of Oumuamua as revealed by scientists. The first image of Oumuamua. NASA's James Webb Space Telescope has captured the first actual image of Oumuamua, a mysterious interstellar object that has brought debate and speculation. Its reddish hue suggests a composition rich in minerals and metals, indicating a history of exposure to cosmic rays over millions of years. Oumuamua's elongated cigar-like shape contradicts preconceived conceptions about what interstellar objects might look like, providing significant insights into the materials and conditions found in distant star systems. The sight of this mystery object was unlike anything seen previously. Oumuamua was long and narrow, like a pancake. It measured around 800 meters, about 2,600 feet in length, and 80 meters and 60 feet in breadth. These distinguishing qualities aroused the interest of scientists worldwide. Oumuamua is known for its extrasolar origin, extreme obliqueness, and measured acceleration without a visible coma. By July 2019, most astronomers had determined that it was a natural object, but its precise description is debatable due to the restricted observation time. Although an unconsolidated object, a rubble pile would require Oumuamua to have a density equivalent to stony asteroids. A small amount of internal strength, akin to ice comets, would allow it to have a relatively low density. Proposed possibilities for its formation include the remains of a disintegrated comet in nitrogen ice, like Pluto. On March 22, 2023, experts proposed that the observed acceleration was due to the release of entrapped molecular hydrogen that formed through energetic processing of an H2O-rich icy body, which is consistent with Oumuamua being an interstellar comet, originating as a planetesimal relic broadly similar to solar system comets. The James Webb Space Telescope can examine objects that were previously thought to be too old, far, or weak for other telescopes to detect, opening up new avenues for scientific research. The Webb Telescope's ability to smoothly stitch together hundreds or thousands of photos results in a gigantic image that captures every detailed feature of interstellar objects, beyond the capabilities of traditional photographs. Using the Webb telescope, scientists go on a mission to uncover the secrets of the universe that have remained hidden for millennia, pushing the frontiers of our knowledge and understanding of it. The repeated movement changes of Oumuamua as it raced through our solar system at incredible speeds defied all forecasts, adding to the mystery surrounding this celestial traveler. The researchers were even more intrigued when each new piece of data appeared to deepen Oumuamua's cryptic nature, producing more questions than answers. Oumuamua stands out among billions of celestial entities in our galaxy because it is made entirely of rock and metal, with no traces of dust or other celestial components. Webb Telescope can tell us about the makeup of exoplanets' atmospheres. It can observe planetary atmospheres using the transit technique. A transit occurs when a planet moves over the disk of its parent star. Webb also contains coronagraphs, which can be used to picture exoplanets near bright stars. If they are large, bright, and far away, they will just be dots, not vast panoramas. It can also observe planets within or beyond Mars' orbit, as well as satellites, comets, asteroids, and Kuiper Belt objects. Many significant chemicals, ices, and minerals have strong distinctive signatures at the wavelengths. Invasion of Oumuamua. In October 2017, modern space exploration was enriched by a significant milestone. For the first time, experts identified an object in the solar system that was classified as interstellar, but the initial excitement soon turned into lots of predictions. The features of the spacecraft were so peculiar and strange that no scientist had an idea of what they were dealing with at all. The University of Hawaii's Pan-STARRS-1 telescope found 1I 2017 U1 Oumuamua on October 19, 2017. The telescope was supported by NASA's Near-Earth Object Observations (NEOO) program, which identifies and tracks asteroids and comets in Earth's neighborhood. This object was christened Oumuamua, which can be translated to messenger from afar or scout in Hawaiian, and was unlike any other object seen in the solar system. While initially categorized as a comet, observations revealed no traces of cometary activity when it sped by the Sun on September 9, 2017, at 196,000 miles per hour and 87.3 kilometers per second. It was briefly classed as an asteroid before further readings revealed that it was accelerating somewhat, indicating that it acts more like a comet. But still, the confirmation was labeled with lots of questions because its flight behavior broke all known patterns. By the time it was discovered and added to the chart, it had returned to interstellar space. According to experts, it passed through its closest point to the Sun on September 9th. While Oumuamua was approaching our star host up to 37.6 million kilometers, it was racing through space at the speed of 87.3 kilometers per second. It was this movement toward the Sun that left scientists baffled. The studies indicate that this unique object had been floating around the Milky Way for hundreds of millions of years before its unexpected encounter with our star system. The closer analysis revealed a peculiar orbital deflection, which is when the body moves away from the Sun, it flies a little faster than the pure influence of gravity would allow. From this point, researchers have to find out the background of this mysterious movement. At first, the outgassing of the volatile component was listed as a possible explanation. This process is unusual and takes place when the body is strongly heated. However, outgassing is usually accompanied by a significant change in the rotational behavior, which was not a characteristic detected in Oumuamua. Immediately after its discovery, telescopes all over the world, including ESO's Very Large Telescope in Chile, were tasked with measuring the object's orbit, brightness, and color. The need for ground-based telescope viewing was important to get the best data possible. A team of astronomers led by Karen Meach of the Institute for Astronomy in Hawaii discovered that Oumuamua's brightness varies by a factor of 10 as it spins on its axis every 7.3 hours by combining images from the FORS instrument on the ESO telescope, using 4 different filters with those from other large telescopes. No known asteroid or comet in our solar system has such a wide brightness range and a high length-to-width ratio. The most elongated objects we've seen so far are no more than 3 times longer than they are wide. In doing so, they quickly discover that the craft undergoes exceptionally intense brightness fluctuations, which are the size of an oversized cigar. Murch explained that this extraordinarily large range in brightness indicates that the object is extremely elongated, nearly 10 times as long as it is wide, with a complex, twisted shape. We also found that it had a reddish color, similar to objects in the outer solar system, and confirmed that it is completely inert, without the faintest hint of dust around it. These characteristics indicate that Oumuamua is dense, made of rock and probably metals, lacks water and ice, and has a reddish surface caused by irradiation from cosmic rays over hundreds of millions of years. Murch stated that Oumuamua is small and dimly lit. It was not detected in stereo Hi-1A measurements near its perihelion on September 9, 2017, limiting its brightness to around 13.5 magnitude. By the end of October, it had fallen to approximately apparent magnitude 23, and by mid-December 2017, it was too faint and fast-moving to be observed by even the largest ground-based telescopes. Oumuamua's galactic origin drew comparisons to the fictitious extraterrestrial spacecraft Rama. Adding to the coincidence, Both the real and fictitious things are extraordinarily long. Oumuamua's reddish hue and uneven brightness are characteristic of asteroids. A few huge ground-based telescopes continued to follow the dimming object as it moved away from our planet. Two NASA space observatories, Hubble and Spitzer, followed the item as it traveled at approximately 85,700 miles per hour and 38.3 kilometers per second relative to the Sun. Its outward course is approximately 20 degrees above the plane of the planets that orbit the Sun. The object crossed through Mars's orbit on November 1st and will enter Jupiter's orbit in May 2018. In January 2019, Oumuamua will exit our solar system and move towards the constellation Pegasus. Preliminary orbital calculations indicate that the object approached from the approximate direction of the brilliant star Vega in the northern constellation Lyra. Although the interstellar object traveled at a speed of 59,000 miles per hour and 26.4 kilometers per second, it took so long that Vega was not in the same place as the Oumuamua 300,000 years ago. Astronomers think that an interstellar object identical to Oumuamua passes through the inner solar system approximately once a year, but they are faint and difficult to detect and have gone unnoticed until now. Survey telescopes such as Pan-STARRS one have only lately become powerful enough to detect them. Since no dust can be noticed in the immediate V of the object, it's assumed that it contains no water and possibly is entirely made of metal. To determine the exact dimension, the experts had to rely on the estimated data in the absence of a tangible one. Depending on the values entered for the reflective density, internal tensile strength, and axis of rotation, different results. So it's believed that Oumuamua is either 800 or just 100 meters long. The origin of Oumuamua. Concerning the origin of the object, the specialist gave a vague approach that the direction of origin is probably somewhere in the constellation Lyra. There are different predictions about grouping Oumuamua. After it was classified as a comet, it wasn't received by all the experts, which gave birth to future studies. Given Vega's correct speed, it would have taken Oumuamua 600,000 years to reach the solar system. However, as a neighboring star, Vega was not in the same section of the sky at the time. Space scientists estimate that 100 years ago, the object was 83.9 plus or minus 0.090 billion kilometers, 52.1 plus or minus 0.056 billion miles, and 561 plus or minus 0.6 astronomical units away from the Sun and moving at 26.33 kilometers per second. Its speed is very close to the mean motion of material in the Milky Way near the Sun, often known as the local standard of rest, LSR, and particularly close to the mean motion of a small group of red dwarf stars. This velocity profile suggests an extrasolar origin, although it appears to rule out the nearest dozen stars. The closeness of Oumuamua's velocity to the local standard of rest suggests that it has cycled the Milky Way multiple times and may have originated from a different section of the galaxy. It is uncertain how long the object has been traveling through the stars. The solar system is likely Oumuamua's first close encounter since being evicted from its birth star system, maybe many billion years ago. The Carina and Columba associations are now distant from the Lyra constellation, from whence Oumuamua entered the solar system. Others believe it was ejected from a white dwarf system, and that its volatiles were lost when its parent star became a red giant. The object may have passed within 0.16 parseconds and 0.52 light-years of the nearby star TYC 4742100271 around 1.3 million years ago, but its velocity is too high to have originated from that star system, and it most likely just passed through the system's Oort cloud at a relative speed of about 15 km per second and 34,000 miles per hour, 54,000 kilometers per second. An August 2018 study using Gaia Data Release 2 updated the possible past close encounters and identified 4 stars HIP 3757, HD2 92249, Gaia DR2 25029210195654901766, and Gaia DR2 36669929507621413112. That Oumuamua passed relatively close to moderately low velocities in the past few million years. This study identifies future close encounters with Oumuamua on its outgoing route from the Sun. In September 2018, researchers described 5 candidate home star systems from which Oumuamua could have come. In April 2020, astronomers proposed a new theory for the object's origin. One hypothesis suggests that Oumuamua is a fragment from a tidally disrupted planet. If real, Oumuamua would be an unusual object, unlike most extrasolar dusty snowball comets or asteroids. However, this scenario results in cigar-shaped objects, whereas Oumuamua's light curve suggests a disc-like structure. In May 2020, it was proposed that the object was the first to be observed as a member of a class of small H2 ice-rich things that originate at temperatures of about 3K in the cores of enormous molecular clouds. The non-gravitational acceleration and high aspect ratio shape of Oumuamua may be explained in this way. It was eventually determined that hydrogen icebergs cannot survive their trek through interstellar space. Avi Loeb on Oumuamua. Some studies say its body consists of frozen and hydrogen. Possibly, Oumuamua is a stock material ice fragments that was blasted out once from a Pluto-similar exoplanet. A Harvard professor, Avi Loeb, expressed some thoughts on this subject. He said, what if the interstellar visitor has no natural background at all, but was artificially created? Professor Avi, who was born on February 26, 1962, in Beth Hana, Israel, AVB cannot be a controversial researcher. A while ago, the theoretical physicist hit the headlines with a hotly debated topic, where he claimed to have found some mysterious objects of an unknown origin at the bottom of the Pacific Ocean that could hint at extraterrestrial technology. He explained there were hundreds of mini-spheres of interstellar origin, which he recovered in the remains of a meteorite, and spoke of supernatural life. Loeb also participated in the event of an alleged alien mummies presented in Mexican Parliament in September, where he talked about the search for extraterrestrial objects in the atmosphere and the solar system. Loeb later proposed that Oumuamua could be a solar sail from an interstellar spacecraft that uses sunlight to propel through space. In other words, it belonged to the aliens. In 2017, the Pentagon confirmed the research of unidentified flying objects, UFOs, marking a watershed moment for UFO hunters. The $22 million money was also utilized to research claimed UFO encounters and other inexplicable phenomena. Loeb rose to international prominence as a result of the surge in interest. Loeb is also known for recovering spherules, which are tiny glassy beads of metal and rock that were part of the 2014 meteorite from Papua New Guinea. U.S. Space Command telescopes, which are meant to detect hostile missiles, monitored the meteorite. The exact method for measuring object trajectories and positions is classified, but it claimed to be 99.999% positive that the fireball's origins were interstellar. Loeb believes that because the meteorite traveled so quickly and did not burn up high above the Earth, it must have been composed of a more durable, even manufactured material. He stated that the object was faster than 95% of the stars near the Sun, according to what is known as the local standard. That's what made me think it was a spacecraft. It was able to sustain its integrity under extremely high stress. As a result, we concluded that it must be tougher than iron meteorites. So far, Loeb and his team have only recovered microscopic spherules from the meteorite's course, similar to gathering water droplets cascading from a burst water balloon, but they intend to return next spring to search for larger fragments. He further explained that until then, can one identify whether it's a rock or a modern gadget base. And of course, if it's a gadget, it would have screws and possibly buttons on it. After gathering the spherules, Loeb said on television that his discovery was the first time that humans held material belonging to a big object that came from outside the solar system. However, At the time, it was unclear where the spherules had originated, and it's still not. The majority of spherules on Earth are not caused by meteorites. Their origins include volcanoes, the Industrial Revolution, and the Iron Age. As it turned out, Harvard's examination revealed that the samples had peculiar compositions, but whether they are the meteorite Loeb is seeking, much alone if it was formed by extraterrestrials, will require much more research. Desch, Jason Wright of Penn State University, and Sean Raymond of the University of Bordeaux in France disputed this notion in a Medium essay, concluding that there is no evidence that Oumuamua was a spacecraft. Different perspectives on Oumuamua. There are two primary hypotheses for what Oumuamua could be. Alan Jackson and Steve Desch of Arizona State University argue that Oumuamua is a piece of nitrogen ice. When New Horizons sailed past Pluto in 2015, it discovered places like Sputnik Planitia that were effectively frozen nitrogen lakes. Jackson and Desch proposed that Oumuamua could be a chunk of nitrogen ice blasted off of a Pluto-like body by a massive impact. Outgassing nitrogen, melted by the sun's heat, would have provided the extra push Oumuamua required. Nitrogen would have given Oumuamua an albedo of 0.64, which is more reflective than a regular comet. Therefore, Oumuamua would have had to be smaller than believed to seem so pale. Nitrogen would also have given Oumuamua an albedo of 0.64, which is more reflective than a typical comet, implying that it must have been smaller than previously thought to seem so dim. Jackson and Desch determined that if Oumuamua was constructed from nitrogen ice, the object's dimensions would be just 148 by 144 by 25 feet and 5 by 44 by 7.5 meters. Now, a team of researchers claims that Oumuamua was a comet, although one with an odd appearance. The leader of the study, Jennifer, said, "We can explain a lot of the strange behavior." Jennifer Bergner was a chemist at the University of California, Berkeley, who studies frozen space objects, and Seligman, a planetary scientist at Cornell University, argued that the comet emitted hydrogen into space. Finally, this gave the comet an acceleration boost. Marco Micheli, an astronomer at the European Space Agency in Italy, who was not involved in the research, affirms that their analysis is the most convincing model so far for Oumuamua. He claims that the alien visitor was similar to comets in our solar system. Seligman stated that what's beautiful about Jenny's idea is that it's exactly what should happen to interstellar comets. We had all these stupid ideas, like hydrogen icebergs and other crazy things, and it's just the most generic explanation. Dr. Bergner, an expert on the chemistry of ice in outer space, questioned if the comet was propelled by molecular hydrogen gas, the universe's lightest, most abundant, and most volatile element. But where had the gas originated from? She discovered that laboratory research dating back to the 1970s demonstrated that when ice is attacked by high-energy particles, its molecules can break apart, releasing tiny bubbles of hydrogen gas trapped several meters deep in the ice. Bergner stated that a comet traveling through the interstellar medium is getting cooked by cosmic radiation, forming hydrogen as a result. She wrote in an email that water ice in its amorphous form has a fluffy structure, with spaces where other volatile molecules can be trapped. As the ice warms, it rearranges into a more stable and compact form. This procedure, according to the researcher, leads to the collapse of these pockets and the formation of channels within the ice through which trapped gas can escape, and any dust in the ice would remain trapped, obscuring the comet's tail. Oumuamua's odd shape made it more than just an interesting object. It was also the first observed visitor from outside our solar system, earning it the unusual designation of interstellar. And most importantly, it did not behave like other comets, which are primarily composed of ice. When other comets approach the sun, the heat causes them to produce a trail of water vapor, gas, and dust, leaving behind a distinctive tail that can move or drive the object. But little Oumuamua, at just some 115 meters long, couldn't possibly emit so much water, and astronomers couldn't discern any tail. Space is brimming with radiation. When this radiation strikes water ice, it generates hydrogen, which becomes trapped on or just beneath the comet's surface. Finally, when sunlight struck Oumuamua, it released the gas. According to Dr. Bergner, this gas discharge would have a modest effect on a comet of normal size. But because Oumuamua was so small, we think that it produced sufficient force to power this acceleration. Bergner said for a comet several kilometers across, the outgassing would be from a really thin shell relative to the bulk of the object. So both compositionally and in terms of any acceleration, you wouldn't necessarily expect that to be a detectable effect. But because Oumuamua was so small, we believe it produced enough force to power this acceleration. Other solar systems also feature fast-moving ice particles. After all, the universe is full of water. Space scientists will most likely see a lot more of these strange cosmic guests when larger and more capable telescopes. However, they are fascinating travelers from remote worlds of our galaxy. Previously, experts hypothesized that Oumuamua could be an asteroid or a piece of hydrogen ice generated in a frigid interstellar cloud of dust and gas. Seligman, who offered the notion in 2020, now supports the comet explanation. He said this theory explains every single weird aspect of Oumuamua. It looks just like an intergalactic comet. There were also widely disproved rumors that Oumuamua was an alien probe firing a thruster as it went past our sun. Berger responds that the rumor can be ruled out now. She hinted that Oumuamua can no longer be studied with telescopes. The object has now passed Neptune's orbit on its journey out of the solar system, so we'll never truly know the identity of this object. Indeed, in recent years, astronomers such as Dr. Seligman and his colleagues have discovered half a dozen dark comets, small particles that accelerate but lack apparent comas or tails. Dr. Bergner stated that while hydrogen jets are not likely to be the cause in every occurrence, together they reveal that there is much to be learned about the nature of small bodies in the solar system. Alan Fitzsimmons, an astronomer at Queen's University Belfast, believes the research provides a good explanation for what Oumuamua was as it pulls everything together. Karen Meach, a space scientist at the University of Hawaii, Manoa, does not rule out a more straightforward explanation. She said, "I still felt a normal comet model would work, noting that the object could have simply had a low amount of dust. However, I believe this is an innovative model, so it might be correct. However, more of such items are to be expected." A prospective European mission called Comet Interceptor will circle beyond the moon in the hopes of detecting a future interstellar object as it passes through the solar system. Berger stated that hopefully we can be ready for the next one. A second interstellar object was detected in 2019, and Meach believes there is always at least one inside Earth's orbit, closer to the Sun. She said, "It's just that we don't see them, because they're either small, they're dark, or they're not in a position where you can point telescopes." The new Vera C. Rubin Observatory, scheduled to debut in 2024, is expected to be a game-changer. Meach goes on to say, they're predicting maybe one interstellar object a year. This is significant since the closest star system to our own is more than 4 light-years away, and sending a probe there would take thousands of years with current technology. What are your thoughts about this space visitor? Leave them in the comments section, and don't forget to like, share, and subscribe for more historical content.